Let me mute for a second. So we can start. More people can join throughout the lecture. So feel free to introduce yourself. Thank you for being with us. We're looking forward to this lecture.
Okay,
thank you.
تمام. Thank you. Okay, let me start then sharing screen. Stronger. I guess you can't see my screen yet. Start with this. Hey, مرحبا, مساء الخير. I should be speaking English or Arabic or
English ودخل فيه شوية عربي for both people بس على الأغلب so far كل attendees بيحكوا عربي I suppose it's fine. Whatever suits you, Batoul. Go ahead.
Well, good evening, everyone. I'm Batoul Rajdan. I'm an architect, and now I'm more specialized in the digital fabrication and high-tech designs. And welcome to this lecture, which is about 3D printing and technology for smart wearables. Okay. As I said, I've been always passionate about technology, science and technology, and that's why I like to merge it with design. And I approach usually design methodologies using cutting-edge technology and digital fabrication tools. And I usually like to create projects related to the people, whether directly through by creating my own sensors, as I create my own sensors for some projects, or related to their cultural and heritage background, or to a certain place they live in, highlighting a certain environmental concern. So most of my projects are related to the people, as I said, directly or indirectly. And I would like to start with the computational couture. This is a very interesting project of mine. I've been experimenting and developing it throughout the research for some time. I designed parametrically the cross stitch. I'm sure you're all familiar with the embroidery that represents our tradition and reflect the culture. So I've thought why can it be upgraded with some technology? So I thought of using this cross stitch or half stitch. In this case, I used a cross stitch as my basic element that I used later on with that I coded through Grasshopper. I'm sure you're all architects are familiar with it. So I use it as the basic cell to grow patterns. And instead of having old women making the cross stitch as base element and creating a whole outfit, it's the 3D printer, it would be creating that cross stitch and in different shapes and creating different geometries as a whole. This cross stitch would work in the same mechanism as the traditional one, which would create at the end a flower or a moon or these shapes that usually have a deeper meaning in our culture. So you can see here, like I usually create like a certain catalog digitally before I explore it digitally before I actually transform it physically using the printer. I develop lots of and I like to experiment with like lots of materials, lots of methodologies that I explain later on each. At first, like I started exploring printing the entire axis with PLA, which is a rigid material somehow for those who don't know. And to print a textile, here's like, there was there's a missing slide. Okay, so usually like in additive manufacturing, based on my personal experience, you have like you 3D print a textile and you need at the end of the day to make it somehow flexible because you're wearing it, right? Or we're not following up. So like to maintain that flexibility somehow, you either print the rigid material on a flexible tool or like some sort of fabric that has holes so that the 3D print can stick on it, or you print a flexi on the fabric, or whether like the tool or lycra, or you print using on biomaterials that you create your own material and print on it sometimes, or you print the textile as itself, like and to make it flexible, if you're using rigid materials, you print it with joints, and or you print it with flexible material, flexible filaments. Filaments are usually the material that you put behind the printer or inside the printer to actually print it. As you all print, I'm not sure if you're all familiar with it, how the 3D printer works. It just start building layer by layer and it adds on it. So that's why it's additive manufacturing. And some of the flexible filaments or materials used in the 3D printer can be flexible, and you usually market it as flexible, like the TPU 95A and the Felaflex. They're usually like very flexible. So these are the basic methods of obtaining flexibility in terms of 3D printing. Okay, here are like some of the shapes I usually get like inspired from, some of the the embroidery patterns that created. I usually use them, as I said, and I integrate the cell generation. Like I make the cell, my basic cell is the X, and this X I coded to make the entire shape of the embroidery I want to create. These are created to be fabricated with the flexible filament, which is TPU, not Felaflex. I use the wet box machine 3D printer to actually print these flexible textiles. And here you can see I fabricated that mannequin so I can actually use it, but I didn't put it in the slides how I fabricated it because I felt it's off topic a little bit in terms of I wanted to focus more on the projects that are related to the heritage. These are like two textiles I fabricated. This is the entire collection. Here you can see the flexible on fabric, the rigid on fabric, and the rigid on the biomaterials. That's, I'm sure you're all familiar with the moon shape of the embroidery. It was also created via coding and parametric design. This is how I set the settings of the 3D printer. Of course, there are, as I said, additive manufacturing works by melting the material, and it pours layer by layer until it builds your design. And in terms of like to prepare that, to prepare your print, of course, there are several settings. You can set the height, whether you want it like, if you want more details, you need to set the layer height to the lowest, so you get more details. If you want it faster, just a quick prototype, you need to test certain things. You make the layer height here over here higher. And there are like wall thickness, top and bottom layer. These are very technical details. I'm not gonna get into it deeply, but just to know. And the infill, like usually use it once you have like the roof of something. Let's, for example, you're planting a box, like the top of it, so it's not gonna build on air. It's gonna build like it needs support to actually hold the top of it, and then you can later on remove it. But that I like the support, and so certain things like you usually don't use for the printing on textile. The infill is like what's inside. Okay, you set it like depending on the cause, and the material, you usually set the material so it knows the temperature. The extruder knows the temperature of the material, so it knows when it melts. So it starts melting it based on the temperature that specific material melts. For example, like the CPU and the Teleflex, they are printed on higher temperature than the PLA. That's why it's important you know the material and you know the temperature at which it melts. You usually read the data sheet of the material. I'm not gonna get more into the technical details. We can move on. Okay, here you can see like how I code them via grasshopper, and how the pattern start growing, and how I start modifying. Just like quick video, and here's another example. Okay, here I was printing TPU. TPU usually marketed as like a flexible filament, but it's not as flexible as the Filaflex. Filaflex is more flexible. And here you can see how I play with the parameters to actually parametrically design my piece. And here you can see how the basic element is the X, and then it goes into the field of X's. And these field of X's, like they usually have a certain shape I said earlier. And then I play with their heights. And that's the cool technological part about like the digital embroidery, let's say, and the 3D printed embroidery. It doesn't have to be the threads, just like one height and that's it. You can play with the heights and you can boost it more. I guess that's really interesting for designers, fashion designers, and all to kind of play with. Sorry, maybe I need to shift these. Okay, I'm gonna jump to the e-textiles now because videos. One more thing, I guess I need to show you this because like 3D printing on fabric isn't just like 3D printing on fabric. There are certain methodologies you can use to transform, to even enhance it more in terms of how you want the shape to be. Like you can print, like for example, 3D printing, I don't know why this video doesn't work. I was experimenting on a certain pattern, like this one. Okay, this one, where I was printing using Filaflex on the wet box. I printed just a few layers on a flexible tool, and I only printed like 2 layers, and as you can see here, it was like flat. because I know like how would it react then, because printing like a rigid on some sort of rigidity on the flexible thing, it would set a limitation on how the fabric moves. And then here you can see it's transformed into a buffy kind of shape. So you just like, I know this would happen. So there are like certain experiments you can experiment with. You don't have to build million layers to get the 3D effect. You can also get it by printing 2 layers. As you can see here, the moon geometry that I was able to create this with. Here we come with forward. I'm sorry. Now for the e-textile, as I said, like sometimes some projects I develop my own sensor. I've been like experimenting throughout the years with the flexible, how to create a flexible sensor, stretch sensor, and so on. As we all know, like there's this cultural headband and headpiece possible. Usually women wear the traditional clothing. I wanted to upgrade that in using technology. So I created this stretch sensor that it changes its reading once stretched. It was like a DIY sensor I created at the lab, and I connected it. It's considered my input. I connected to a painting. I painted it to actually connect it to the LED. So like you're wearing a headband that's actually lighting a head that controls the light on a headband on an art piece. So it's an interactive art related to the culture and heritage, and I code them via Arduino. As you can see here, I'll show you a video. And here you can like focus on the frequency of the LED once the stretch sensor is stretched, because the code, I coded it to play with the frequency of the LED. Like once it's stretched, it controls the blinking frequency. And once it's released, you can see it's blinking a lot. And that's the code I used via Arduino software to program the electronics, which I used like other foods.
Batoul, can I interrupt?
Sorry.
Can I interrupt a bit? I want to ask you a question regarding this because it's very interesting. Like I haven't seen this before. شو السنسورز اللي استعملتيها أو
I made my own sensor. It's called I made my own sensor. Oh.
يعني how does يعني كيف الماتيريال هاي it's fabric, is it inductive يعني هي بتوصل الإشي يعني it's very
yes,
nice.
it's a mixture between a fabric and conductive threads.
Oof,
it
so nice.
creates the sensor, and then I code it so it behaves the way you see. Of course, there are other forms, but as I said, like for this presentation, I only put the ones related to the heritage and culture, because I've been like creating this sensor for a long time. Different forms of it, because I had another interactive project, interactive art, where I developed this like this glove controller, and like I scanned my hand and I lit the bar and I grow in my hand, and this sensor was like when you bend your finger, the 3D printed pattern on the wall starts moving. So that
Wow.
was another form of a sensor that I created, but I didn't find it relative to the heritage and culture, so I didn't put it here.
لا بس يعني this has many applications فيعني this takes the whole
Yes, yes,
embroidery
yes.
and printing and textures into a whole new level فيعني تخيلي انت how you can interact through هاي البيسز او through هاي الفابريكس مع كتير اشياء يعني art for the example that you've put here فيعني this has many applications yes please carry on بس كان بدي اسال هاي الشغله انه كيف القماش عم
Yes, not even artistic applications, by the way. You can control, like, for people with disability, like, because at the end of the day, this is an input, and you can play with the coding to code it to a certain output you want or you have in mind. For example, my glove controller, okay, I controlled art with it, but for example, at some point, my grandma was like using it to close the curtains from a distance. Like, you can recode it. Well, I
Nice.
recoded it for her.
كملي sorry for the interruption but it was
No, it's okay.
I had to know thank you.
So, and another form of like project related to the heritage and culture was this wood textile. As you all know, wood is well known for being a very rigid, like a rigid material to a certain extent. And what's cool about this project, I was playing with the material characteristics to actually start bending the wool and make it more flexible. And for the pattern, and experimenting with this technique for quite a few times, and I discovered like these shapes, the triangles, they give me the movements, the flexibility I want in the wood. That's why I use the laser cutter to actually create them. And for the shape, it was inspired from this very like well-known Ribdawi embroidery from my home country and my origin. I transformed the let's say the geometry of it into these triangles and wood textile, and then here you can see it when it's flat, and then now you can see how I divided on rhino the triangles. So I follow this pattern to end up with the wood textile you saw. Here's a zoom in, and here how they bend. Like, you see, it's not flat anymore; it's bendable. And for the coloring, to obtain the Ribdawi pattern colors, these colors you see, I used bio dyes. I created my own dyes. I didn't use artificial coloring because, like, to a certain extent, I like to be environmentally friendly. I was experimenting how to get get colors out of natural ingredients like the onion peels, dye bath, or beetroot, and to experiment just like with whatever I found locally, and to paint the wood I used to actually at the end have the pattern used. So, and this is like application how you can use the wood textile. You can see it can be bended as an art piece in the middle of the table. You can wear it skirt on your like shoulders, or you can put it as flat. You can put it on the sofa, on the couch, and just bendable, whether you use it as like art on its own or you use it with the home furniture. You're actually wearing it, so it has like lots of applications. Depends on, like, it can be like inspirations for others who have actually a certain like different measures to play with it. Let's say it's a technique and for others to get inspired from. And now for the skin electronics, this is another cool project of mine. I like to bring electronics nearer to my body, as you can all see. And this is the nearest thing you can get on your skin. Very, very near to your skin. As you all, you're familiar with the mask with coins, the traditional one, and also with the tattoo that our like grandmas used to have, the dagga, and each shape has like a meaning. As you know, it's part of the heritage and culture. So I was inspired from them, and now you can see how I integrated technology into them. So of course, you like using materials that are in the market is too cliche, and I like to develop my own material and play with it. These are biomaterials. They're created, I'm not sure, like, to make it more interactive, can you guess what is the material? Like, just random guessing, what could it possibly be? Anyone?
صعب والله. صعب. It looks like
Hi.
gold. Is it biomaterials يعني من شيء
Biomaterials, بس biomaterials من شو؟ That's the trick.
مش عارفة، قشر بصل، خشب. هاي بيحكوا لك خشب. Is it wood?
قشر البصل, yes, actually,
Is it
yes.
بصل؟
No, it's قشر البصل. Yes.
والله.
So to get
Nice.
this golden look, like, and then that I lasered cut and I designed this like, well, at first I went to the shop, I took the measurements of the Turkish lira, that's like part of our culture too. And then I drew the design on Rhino, and to use that design, I engraved the design on the biomaterials I made using the Trotic laser cutter, and then I cut the coins, and then I used these coins to create the burqa, which is the traditional mask. And this mask, I integrated electronics in it, which as you can see here in the headband, there are like these LEDs, lights, are controlled by the tattoo I have on my face over here. So I'm not sure I can point. Can you see the pointing? It's right here. So once you press on the tattoo, you switch on or off the mask, the lights on the mask. So another form of interactive.
فخامة صراحة هذا الذهب من قشر البصل. I love it. So nice.
Thank you. And you can see it once it's the light is on and off. And as I said, you control it via the two. And here's like behind the scenes, like how I touch it and then it's switched on, how I touch it again to switch it off. Of course, I code it as well, like the other projects with a microcontroller and the Arduino software. This is a project had been created in collaboration, of course, like in collaboration with different parties throughout at the TechWorks Lab, which is one of the initiatives from the Crown Prince Foundation, with the Fab Academy and the Hello Studio in Berlin. They usually create these open source spinning machines that people elsewhere can 3D print the parts and gather them together. Here, like you can see, we 3D printed these parts at TechWorks, and it's like a DIY machine. The concept of it is like to create your own threads. As you know, like the threads in the market or the factors that create threads sets a limitation on you as a designer and doesn't give this flexibility in what sort of threads you want to make or what like the resource of the thing you're making the thread out of. And as you all know, also, Jordan is like one of the countries that has lots of excess wool, usually thrown away. So it's good to use that wool and sometimes like mix it with other things. For example, I mix it with conductive threads and create my own threads using that machine. So, okay, here's a video of it working. I have a problem with the videos. I guess this don't work. Okay, no, shall work. And you can see how the servo motors start moving the spanning. Here, like we have 2 servo motors. In this entire machine, it has 4 servo motors, as you can see. And here it start like spanning the threads, like the inputs you have, and spanning it into a thread. Now, to my favorite project. It's related to Jordan, but in a different way. As you all know, it's mostly related to Dead Sea, because as you all know, it's the levels of Dead Sea are the levels of water at the Dead Sea, they're dropping by 33% and even more. And the minerals also. So I wanted to highlight that environmental concern by creating this a 3D printed wearable. And this character is like a defender, a goddess coming out of that sea, protecting its resources from people abusing these resources. So it was like entirely 3D printed, and it has I'll let you see the video and then I'll explain how I did it.
باتول المايك، افتح المايك.
You muted me again. Anyway, So this was a final project I created with a like I was granted a scholarship from Zing, Design, and TechWorks and Prep Academy to actually do this project. Was entirely fabricated at TechWorks, and now I'll talk about the how I developed it. So as you all know, this is like the environmental concern that made me start with it. Like I came up with the concept. So I thought like no one is highlighting it, or at least I wanted to highlight it in my way, in a unique way, and using technology. So I created this creature with the that's inspired from the Greek myths and legends, or like myth creatures that had been there, the sea creatures, monsters that used to defend their places, let's say. And as well, like as you see, the dress had been inspired from the color palette of the Dead Sea to create some sort of camouflage and counter shading with the Dead Sea, so it's like blends in with the environment. This was inspired from the animals that actually mimic their environment. There are like lots of animals that they go certain places and they start changing color or whatever to mimic their surroundings. I was inspired from that, so I thought I'll start by collecting pictures of that sea and check the color palette, analyze it to come up with the. And also, as you saw, there had been some parts that glow in the dark, or I can show you later how I developed this. But it was inspired from the animals, the bioluminescence of animals. These are like animals that emit lights. They live deep in the deepest level of the ocean, which is the twilight zone. And as you know, Dead Sea is the lowest point on Earth, so there's nothing lower and nothing deeper than it. So I thought it would be cool to integrate that using technology inspired from the bioluminescence of animals. Here I was also creating my own crystals, the cup crystals that I had placed on the wing. These are all lab-grown crystals using copper. Also, like I was growing crystals on optic fibers. Optic fibers, they're like, for those who don't know, they transfer light. So from the source to somewhere further, I used on my shoulders, if you saw in the video, like my shoulders were lit, they had light, and this light was coming originally from another place, but these had crystals on. So you can see here how the crystals, they have light in it and them. So yep. Here you can see it clear. Also, like I coded the colors to be also the colors of Dead Sea, turquoise, and the navy blue, and so on. These are lights transmitted with the optic fiber, and that I grew crystals on. And to mimic, as I said, like I wanted to mimic the crystals of Dead Sea, and the crystals of Dead Sea, some of the crystals, they don't have like the very white colors. So like when created at the lab, it gives you the very whitish color. And I was like, nope, I want, like, they look a bit dirty because they're ruined and people are abusing them. So I wanted to create more of an off-whitish color, or like a more dirty color. I used the onion peels again to extract the color, the bio dye, the biochrome that I used to grow the crystals. And you can see here when I use the dye bath, and then I let the crystals grow in the dye bath so they take the color. What's wrong with the internet? And here's like a comparison between the lab-grown crystals and the real crystals I collected from the Dead Sea. They were just like there are like some crystals that were like aside and smashed. They have I managed to mimic them exactly and to get the color as well. These crystals, you find them on the 3D printed, like I 3D printed the mannequin that's worn, and on it I had some crystals grown too. And on the crown, I'll explain later. And to develop these crystals, I developed a catalog to help other researchers to follow up after me, for example, or if they needed to check it out, to learn from it. It's like I was recording how each additive would influence the growth of the crystals, and and to calculate the growth rates of the crystals. As you all know, like the crystals have different geometries. There are like some sort of the branching ones, the sharp pointy ones that I had on the headpiece, and like the bubbly ones, the smashed ones, like so I was like studying these geometries so I know where to place them and how to integrate them into my project, because I wanted to mimic them. And the sharp ones, I mimicked them by like the ones you saw on the optic fibers. The bubbly one was on the main piece that I'll show you later. The branching one was on the wing, and the coin dropping one was on the headpiece. The headpiece had actually more of the geometries, like it collected all of the geometries. Here's how I started. So I started by tracing these geometries as a baseline to my parametric design later on. So let's move. And here you can see the 3D printed wing. I printed using the wasp machine. It's 1 meter in length, each wing. Though I also used the color palette of the Dead Sea that I set earlier. The thing is, when you're like a digital fabricator and you're like experienced with I've been in this domain for quite long time, or some years, so you start designing for the machine and you know how the machine works. So like I know the extruder would go like 1 round, so I make like the wing go like maybe 1 round or double round. So I designed the width based on the printer and the extruder of the printer, so it actually goes once and doesn't start filling it up between the lines or so on. This technique is called spiralized technique, so I managed to master it throughout the years, to experiment with it and master it. Here you can see the parametric design of the main piece and the crown, with the bubble geometry of the crystals. What's really cool about this project too, I managed to print it with 1 spool only, which is very unique in the world of digital fabrication. Usually people print with lots of infill, lots of support, and like you get lots of material loss. And I wanted to optimize that by using the spiralized technique. So it's hollow on the inside, it just prints the shell. And usually it's hard to target that because you need to count the angles while like designing. So you need to consider everything. And here you can see some of the parametric design with grasshopper. The internet decided to stop functioning a little bit. Okay, I 3D scanned my body first to get like the base that I can grow these crystals on, because surely I believe in this. I'm an architect, but I do create wearable architecture. So I let this coding grow on my body scan, as I said. So that's a concept I've been fascinated about. And for the headpiece, as I said, was inspired from the goddess, the sea goddess, and the sea creatures and the defenders, let's say, because its role is to defend the Dead Sea. So you can see here what's cool about it. It has like the geometries of the the 4 geometries of the crystals, or all geometries of the crystals. And also it has electronics integrated with it. It's like when you touch the crystal, it starts lighting. I'm not sure if you paid attention in the video. And these are like some of the experimentation. I was like trying to mimic the crystals, so I had to design lots of crystals. And here's my the crystal army, I call it, because I 3D printed army of crystals while trying to mimic them, and which one was like the best geometry. Okay, let's try. I'll let you have a look at this. Some of them, the branching one where they were the glow in the dark, and some of them, like here, you can see the grown and you see the 3D printed. And here, as you can see, a close-up to the main piece. As I said, it's like 3D printed, very lightweight, but also I let crystals grow on the 3D printed version. So you have, it's like crystals optimization. It's like Dead Sea crystal optimizations. 3D printed crystals with lab grown crystals. And now this is the back. It was entirely 3D printed. So the brass strap was also printed with the branching geometry of the Dead Sea. Here you can see the designs. And the bracelet was changing color with temperature. So it's shifting between turquoise and blue. That's also the technology. And this is the bioluminescence, how I managed to integrate that with technology. So this is the glow in the dark. I was 3D printing with glow in the dark, so it truly glows on the dark, as you saw in the time lapse in the video. Here's a making of. Here's the headpiece. I actually also 3D printed the headpiece, and then I put it in a fish tank for crystals to grow on. The recipe inside the fish tank is actually lab recipe. It's not, I didn't take from the water of the Dead Sea because I'm here to preserve it. I'm not gonna take from it. So, but the picture was taken there, and it made the result you saw at the end, which is this. You can see how this creature is actually blending with the Dead Sea. So that's it. Thank you. And okay, these are my social media accounts. If you're interested to follow me, or if you have any further questions, anything. Actually, this project had been nominated for a prize, and like I'm the only, not the only Jordanian one, but the only Arab, let's say, in that prize. So it would be very lovely if you can support me and vote for that project. I'll drop the link in the chat for everyone to vote. You just press the like button, the hearts. So it's just like liking the picture. It's considered a vote without subscription or anything. So that's it. Thank you. Let me know if you have any questions. Thank you, Dr. Jansaid.
Thank you very much, Batoul. It's such an interesting lecture, and you're one of the few artists يعني أو architects في الأردن اللي أنا بشوفهم بيشتغلوا هذا الشغل. يعني nonetheless, you're developing your own materials. It's very innovative. أنا أول مرة بشوف هاي الفابريكس that are يعني conductive بوصلوا كهرباء مربوطين في sensors that you can code and interact with. It's genius work صراحة. يعني you deserve our support as a Jordanian and local architect and designer. فبرافو. Thank you for this. I have a few questions. كان في سؤال قبل سألته إنه how do you print rigid على الفابريكس, like how does that process work? وتاني سؤال يعني نفترض إنه مثلا عندنا جماعة people اللي بيشتغلوا بالإمبرويدري هيك and they want to learn more about this. how do you advise them to start مثلا how to transform their designs ل 3D printed embroidery? how expensive is it? وكمان سؤال where do you do your work? يعني لو حدا بالأردن بده يشتغل هذا الشغل ويجرب فيه, لأنه كتير بيعتمد على trial and error صح يعني you gained your experience from trying and failing and trying and so forth.
Right.
فإذا حدا that wants to explore this field وين تنصحيهم يروحوا how to start and so forth. فيلا الأسئلة go ahead.
هلا أول سؤال قلت لي how to 3D print rigid on fabric, right? هلا هلا that's the thing, you know, when you're like when you 3D print textile itself, at the end of the day, as I said, you need to make it flexible عشان إنه بدك أنت textile, you don't need like something
yes
like rigid. When you use like the rigid material, you think of like integrating it with something flexible. So you 3D print, for example, on the fabric, and you specify like certain distances between them. Let's say if you're printing with the X's or so on, because you need to have in mind once you're printing rigid, it limits the flexibility of the flexible fabric. So you design accordingly. Like whenever you want some limitation set on the fabric, or you need to consider once you put that pattern or whatever, it sets like limitation. And that's the cool thing about the X's, because like you can create whatever shape you want, but somehow the basic element, the X, is like, it can be rigid, but there are like distances between each X and so on. But the outer image is like another image. I usually use tulle because like it's better to use a fabric that has holes so that this rigid material can be integrated in it.
Okay nice. طيب السؤال الثاني إنه كيف تنصحين like how would you advise أي حدا بيشتغل أصلا embroidery إنه how to start if they want to integrate this what's your advice how to start this خاصة small businesses أو بتعرفي كتير في جمعيات that actually do this work. If they want to start with 3D printing and experiment with it, what's your advice? How to begin?
You need to know, I would recommend you know the basics of digital fabrication, because once you know the basics of how the machine works, you know how to design for it, and with like somehow enhance your design, because مش يعني أي شيء you design it can be printable in the best way, like with the best outcome you can think out of mind. The more you know how the machine works, the more you can actually deal with it. And regarding where I've done these projects, I've done them via TechWorks, which is واحدة من مبادرات مؤسسة ولي العهد. It's an open space. They actually like welcome you if you have project in mind to work there, to use the 3D printer, and they charge you on that, based on that. And I'll start actually giving some lectures there بعد أسبوع.
Nice.
Whoever interested to learn the basics, they're welcome to join. The workshops are for free, and I'll drop all the information maybe throughout my social media or through you, for whoever interested to learn the basics or to learn more about 3D print textiles, biomaterial, and
that's very nice. يعني برضه it opens the room ل spin-offs startups يعني that want to do this work. إنه في كتير لها مجال applications خاصة في هاي الشغلات يعني small artworks, embroidery and so forth. It's really good to know there are some people who are offering lectures, offering these workshops that you can attend for free and even learn and develop your own work. Yes. It's very interesting. فبعتيلي if you conduct any courses لقدام,
yes,
we can share them. أنا بستشير الجمعية, we can share them. Maybe we can even partner because you have your own office in your own SME, let's say, or startup.
Yes, these projects, these workshops, I'm actually like conducting مع Design Zinc and TechWorks, but I'll be conducting them via TechWorks Lab, which is, as I said, هي مع مؤسسة ولي العهد. I'm giving like 15 workshops. Of course, you're welcome to join them. They're free. And later on, maybe I'll start making my own. But yeah, so let me know, whoever is interested to start. I'm willing to actually give you the initial steps, let's say.
It's very, very, very nice. يعني very innovative صراحة. يعني thank you for this lecture. يعني maybe in the future you can also tell us شو الماشينز اللي بتستعمليها بالضبط and
I
everything maybe.
actually said them throughout the presentation بس I was stating كل واحدة شيء. Yeah, the wet box is the name of a machine, and wasp, the Ultimaker, I said them several times.
وهذول الماشينز كلها موجودين في الأردن in the space you
Yes,
work
yes.
in.
This project, this dress actually entirely was fabricated في الأردن.
Okay, very nice.
Yeah.
أنا ما كان عندي يعني I didn't know إنه في هاي الأشياء و they're open for use for everyone to learn and go ahead. هلا مشروعنا إحنا بيختص في البتراء، iHeritage it's very specific towards Petra and trying to preserve that. فلما الواحد يفكر فيها بالconcept that you can come up with that can be inspired from the Rose City، ففي كتير applications يعني، وخاصة هلا في مسابقة جاي مع دائرة الآثار that is promoting إن الناس تفكر ب concepts and so forth. So if we can think of something that is inspired by Petra and the textures تبعت الحجر والpatterns هاي and try to 3D print it and envision such a project ويطبقوها الناس بهذا الحكي، ف it's a very nice opportunity that I encourage كل حدا مشارك بالليفينج لابس to consider. فيعني contact architect بتول، أنا عم بتبرع عنك، feel free to contact her
Yeah,
to
sure, feel free.
learn more about this work and how this can be done, and maybe you can apply للمسابقة بإشي زي هيك. yes, thank you very much. فإذا في أي كمان أسئلة please go ahead.
I have a question. أول إشي, thank you so much, Batoul. It was an amazing lecture. It was very inspiring و brilliant work صراحة. My question is related to biomaterials specifically. Materials you mentioned إنه استخدمتي قشر البصل والبيتروت، فبدي أعرف بس إيش الأديتيفز اللي استخدمتيها مع هدول الماتيريالز علشان يصير عندك الكونسيستنسي تبعت الفابريك، إنه ما يكون إنه إشي إنه بس هيك waste، يكون لا actual fabric that you can use. وكمان follow up question على هذا الإشي إنه how durable is this fabric، إنه قد إيه ممكن يضاين، أو هل مثلا إذا بتستعمليه كتير أو بيندعك كتير ممكن إنه ما بعرف يفرط أو يخرب أو يصير في إشي. This is my question. Well, thank you again.
Thank you, Noor. Your support, and thank you for the questions. The thing is, like, these biomaterials are made to be environmentally friendly, but like they're better, they are behaving like as biodegradable, so they won't last forever. You're just I use them because, like, at the end of the day, like, for example, when we're talking about onion peels, it's a waste, it's already wasted, so I use it, and like I'm okay with it being environmentally friendly, and I use it because I want to protect the environment. It's already a waste, and I'm creating a biodegradable like textile out of it that wouldn't last forever. Like I don't want it to last forever. Like, it all happened and it all started from as you all know, the waste that plastic, for example, is, and the pollution that's created by the plastic, the cliche plastic that's been used. So these bioplastics or biomaterials had been, like, researchers have been developing throughout the years to actually create an alternative to that plastic. But of course there isn't, like, they didn't manage to find, like, the perfect alternative, but it was like some trials, because we don't want materials that last forever anymore. We actually want to protect our environment, because if we keep creating materials that stay forever, like, we would have lots of waste, and then we would have no place to live at, because the entire place is filled with waste that's covering even us, and we would eventually die. And that's why, like, we started with the biomaterial, and lots of other researchers and courses like Fabric Academy and other courses, they're teaching students or others how to develop these biomaterials. You mix it with a polymer, preferably a plant-based polymer, and another element to create actually flexibility, and water, and the waste material you're actually using. For me, like, I use this recipe. There are lots of other recipes out there. I can share them with you, and depends on the application you want to create. For example, if you want them to be water resistant, it's better if you use the alginate. And if you want them more flexible, so it depends on the application. Like millions of recipes.
Thank you, Batoul.
Batoul,
عندك كمان سؤال.
Yes.
Go ahead.
Nermeen.
Yes, معك تمام.
Hanan, yes.
Hanan, go ahead, please.
Thank you. Batoul, thank you very much for your lecture and for giving us this chance to have an idea about your projects. And they are really creative projects. So would you please leave your phone numbers? It would be my pleasure to contact you and see how can we cooperate together. And I'm
For sure.
Hanan.
I dropped, these are my social media accounts. Like, feel free to follow me. I answer. I'm like 24/7 available, and I'll drop down my phone number in the chat.
Okay, thank you.
في عنا كمان سؤال بالchat بتول. I'm gonna read it out. فالسؤال
Yeah, I read it.
you used Grasshopper for parameterization. So Grasshopper is a parametric modeling software. I did not understand the transition from الموديل اللي عم يعمل بالGrasshopper to a 3D printing supposed to give a 3D model.
Miss, you didn't understand. You didn't follow up in the lecture because I mentioned it in a slide. I was explaining and I was like, okay, I don't want to get very technical about it. It was through a transition software. It's called Cura. And using this Cura, you actually set the settings of the 3D printer. Firstly, you start by exporting your model STL format, and you take that STL format, you take it to that software. It's like there are lots of softwares. I usually use Cura. Cura, it's made for Ultimaker and some other printers. You can't use it on all the printers, but depends on the printer you're using. It has its own slicing software. And on this slicing software, you actually set the settings of the thing you want to 3D print in terms of the layer height. As we also like, the 3D printer works by putting layer by layer. So sometimes you need a very quick prototype. You just need to test it out. So you put the layer height higher and you don't care about the quality. And sometimes you need to print a final project or like the final outcome, and you need like the best quality ever. So you minimize the layer height so you get finer details, let's say. And for support, for the infill, and you specify like a lot of things, and most importantly, you specify the material you're using so the 3D printer knows at what temperature this material melts, so it's short like 3D printing it.
فإذا أنا فهمت صح, the entire process أول شيء starts by أول شيء concept. Okay, you make your mood board, you get inspired and you design, let's say by sketching or tracing. Then you take it like Grasshopper, where you design.
You don't have to use Grasshopper. You can use whatever software, design software you're familiar with, you're comfortable with. At the end of the day, you just get your 3D, let's say. It doesn't have to be parametric. If you're like super good, you transform everything into a parametric design. But if you're like the normal design is okay, so you end up with like your 3D design on a software, and then so you export from that design software. You export it as STL.
Okay, you export as STL, بعدين بتدخليه على برنامج Cura اسمه.
Slicing, مش Cura, slicing software. I use Cura. It depends on the printer. It's called slicing software. It depends on the printer. Like Cura is like related to Ultimaker and some other printers.
Okay. Yeah, makes sense. So you design, export 3D, put it in the software, then you adjust the parameters according to the machine بتستعمليها والmaterials, and then you go ahead and print.
هلا slicing software وظيفته إنه يعطيني G code. لأنه إنه ما يعني ال 3D printer ما بتفهم إنه هذا مثلاً I'm 3D printing تاج. لا بتفهم إنه بالأكسيس بتتحرك X هالقد Y هالقد Z هالقد، فإنه بس بتفهم إنه تتحرك أكسيس، هذا الحركة جي كود. فعشان نطلع الجي كود من الديزان اللي تاعنا we use slicing software. slicing softwares بتحول إنه هذا ال 3D لجي كود. ال 3D بتقدر 3D printer بتقدر تتحرك بالأكسيس based on it وتصب الماتيريال.
Okay, very nice. Very nice. Thank you. Thank you for the explanation. بس yes it did have يعني the presentation had a lot of information yes طبيعي إنه مش كل حدا to catch with it يعني في كتير كان حكي وكتير مشاريع.
Yeah, please ask يعني if you think.
Thank you for this. If there are any questions please go ahead. يعني إحنا قربنا نخلص ما ضل إشي. If you have any questions ask away. If you have any questions for later يعني contact Batoul either social media. هاي رقم تليفون هضلكم رنوا عليها كل يوم. بس yep, I
most
think
importantly vote for my project and support me. I'm the only Arab competing among Europeans, so it would be lovely.
It's an international مسابقة international يعني.
Yes, it is international. I'm the only Arab there. And I dropped it, like the link of the award is on my social platforms, and I dropped it in the chat also. So you can always press on it and vote for my projects.
We will support you. خلينا نرفع اسم الأردن in such a innovative application صراحة يعني. Let's go ahead and vote. I just voted by the way فيعني. But thank you everyone. I think إذا ما في كمان أسئلة خلاص we're good. Thank you for attending. Thank you Batoul for this amazing lecture. وشكرا على all your work and your innovation. يعني صراحة as a Jordanian practitioner and architect هذا الإشي برفع الراس. Thank you very much for this.
Thank you for having me. وأنا كتير انبسطت معكم. I hope إنه كل حدا يعني لقط كم معلومة. أنا عارفة إنه كتير معلومات لأنه at the end of the day, like these are like several researches like I'm doing, and you don't have to understand them all at once. I just put them there so maybe you can get inspiration from, or it can give you a kickstart to a certain thing you have in mind and you want to merge technology with it. So of course, don't hesitate to ask me if you have further questions, as I said, on my social platforms. And thank you.
Thank you everyone. يعني enjoy your evening. احنا أظن هيك all is good. فيعطيكم ألف عافية ونراكم إن شاء الله في الجمعة القادمة. أوكي يلا يعطيكم العافية كلكم. مع السلامة.